All right. Hello, everybody. Welcome to Crystallize live stream. Happy New Year to those of you that we have not wished through the community channel. Today, I'm here joined by Bort, and we'll discuss today about headless architecture and our opinion on how to make, actually our opinion on headless architecture. That's period, Mr. Bort, right?
No, I think that's pretty accurate, and this is actually a topic we get quite often in discussions with partners and customers. So how does this headless thing work, and APIs, and where do you do integrations, and all of these things. So we'll try to walk through our, of course, opinionated way of looking at architectures, but also show some of the takeaways in terms of what you gain in performance and other goodness.
Yeah.
So
it's quite a big topic, to be honest. So yeah.
It is. And the first thing is we have the traditional way of building web apps. If it's the eCommerce or any
kind, right? So
it's typically you have if you go back 20 years, everybody was building MySQL, PHP, and you had some templates that you can customize. That's a typical traditional monolithic architecture, which you still have around, and there's R4 and all of this. And the approach with headless is, I would say, when iPhones were launched, it was suddenly, we need to have our products in an app on an iPhone. And that is, by definition, you kind of enter in the API way of thinking, because the content from the app needs to be fetched from somewhere, because you don't have a database on your actual phone. And headless is compared to a monolithical or a full traditional stack approach, is basically a decoupling of the backend services, like us from Crystallize, which is product information or rich marketing content, and that you have independent front ends or heads in this context that you can basically plug in. So that's kind of the big overview of what are we talking about when we're talking headless. And of course, why headless? Why would you go this way? And of course, we all know it's a big trend now that you have headless services for a lot of different ecosystems. But some of the points that we really see when we're talking headless is, first of all, it's in terms of front end. You can choose your own front end. What does that mean? Some like to develop in React, maybe with Next.js or another framework. Others like Vue, because they have maybe an ecosystem of Vue already in place, and maybe also with a framework like Nuxt, for example. And then you have Gatsby, which is popular for the Jamstack approach. So it's basically, you can choose your own framework, and in a headless architecture, there's no opinions necessarily from the back end, because you just access the API, and what you do with it, it's really up to you. And that brings us to the next point. And basically what this means is the front-end developers really like when they can choose their framework. And also there's popping up new frameworks all the time, so you can always,
new tech all the time, and things that you can try and play with, right? So
yeah, definitely. And then on the services side, which is, if you look at a monolithical or approach, where you typically buy into, traditionally a single vendor for all of the components of your stack. So you go to Adobe, you get eCommerce, you get all the things you need, or Oracle, for example. But typically, it's not necessarily all the components of a single vendor that's the best in what they do. And with a headless architecture properly done, you can build a poor headless architecture also, but you select the best tool for handling your product information and rich marketing content, for example. In our case, Crystallize. But then for authentication, you're free to choose a different service or payment or email transport, and so on. So you can really build the best of breed stacks. That's kind of the
that you can later on, of course, adjust, and it's like a puzzle. Remove things, add things.
Yeah.
Better, faster, lighter.
Less lock-in also.
Yeah.
And what we're talking about a little bit later is also being able to share services across channels. So I can have the same content service for my website and my iOS app, for example. And as you said, Stavros, if there's a new technology, let's say, might be a new JavaScript framework being released next week. That's probably likely, and the week after. So you will be able to experiment with the new type of framework, or if you want to experiment with the Flutter app, you can really do this experimentation on top of your existing stack without needing to change anything. So it really allows for faster testing and innovating, as you said. And one of the things we really see, because we are, of course, in our own services, we're also using everything is headless, of course. But we can really update the front end or the apps totally independently. So we see that we end up with deploying multiple times per day. So you have this continuous release. It's not, February 15th, we do this big release. We find that we actually release several times a day, and for the different components independently.
For sure. And I remember that we had like this discussion quite a long time, quite a few times actually, where someone from the team, Daniel or Håkon, is like, okay, I found this package, for instance. It's smaller, it's lighter, does the job the way I need it. Why not just use it and push out something that is better quality? And this is exactly what you said. So continuously integrating and pushing it out, something better version every time. So
yeah, continuously improving. And also we find that it's easier to scale, both in the front end and in the call it the service layer, and in the back end. Well, typically the back end would be a vendor you purchase a subscription or access to. So
yeah, for sure.
We'll talk a little bit about that. But in the front end, I just want to show just very quick example. And Jamstack is one of the trends that you probably heard a lot about, which means pre-generating static content, HTML, CSS on the edge. So distributed network. So we have here an example of this is what we call our boilerplate for retail e-commerce. And here you have, rich content, you have videos, you have products, and these products are available here in the design that in this case is actually Didrik that has done the design. But what if we add another head? So here I have a React Native implementation of an app. It uses the same service, the same backend. You have the same capabilities in terms of e-commerce, and you still can use the benefits of navigation and native components that you have in React. This is an example of basically two heads with two different technologies on top of the same backend. And of course, especially when we're talking web, you want to have your front end being super optimized, which means that you often have to use the latest techniques and trends that are being made available. And of course, the ultimate goal is to have a perfect 100 page speed score in Lighthouse. Let's do a test here. And of course, what you want is at least 90 plus, be in the green. That's really the goal. And of course, when you're benchmarking, so on this page, this is from our website, actually the blog post talking about this topic here. We see that we are scoring 100, perfect 100 actually. You typically have a little bit less on mobile, 92 in this case, but it's typically upper 90 we see, and it fluctuates when you do the test over and over.
And this is again here comes again the idea where you continuously optimize the website, right? So you make a change, you deploy something, you don't need to, make full 100, and then something changes from the guys in Google, how they measure stuff, how, how the points are distributed, et cetera, et cetera. So you continuously go after that goal, and it ties up together. So
it's being data driven and continuously optimizing what you're building there. So this is a good example of that. The results of a tailor-made front end, and then you have the performance of it to back it up. Of course, the page speed insights doesn't apply to native apps because there's no standards of way of measuring here. And of course, the goal with being fast is you get a higher ranking in Google. You pay less for ads, and of course, the faster your website or web shop is, the more it converts. So it's proven that you sell more, and people are not bouncing away from your website. Numbers from Google. And what you talked about with deployments, I like that we can use comics to explain architecture. That's our style now. But in a traditional monolithical setup, you would have the UI, the API, the database, the configuration, and everything in the same environment, which means that for many systems, you would actually have to deploy both the, call it the business logic code, and the front end templates or display in order to go live with an iteration, which means very, very slow iterations, because if you're deploying the full stack, you need to do a lot of QA and a lot of tests. Not that you don't need to do tests in the front end, but with Headless,
it will be singularity that breaks also, which is something that can be observed quite a lot of times, right? So
true, and basically what we see is that since we're getting in our own setups, we get deployments multiple times per day, and typically you iterate on the UI, and it could be a web shop or it could be application UI, and we see that the time it takes to deploy something, even with all the CI tests, and you want to test for page speed, and you want to test for all of the things that is important, the time to iterate on a new release is really, really low. So you come from this. If you are in a monolithical setup, you typically have, okay, we release once a month, or you have this kind of, it's the release number 2 of 2021, release number 3, and so on. Whereas with Headless, it's more easy to adopt a continuous deployment strategy and release multiple times per day. And on the easier to scale, I just want to mention this because since you have decoupling of concerns, you can make sure that, as we looked at the front end, we can make that really, really fast and scalable. So both for a single visitor, but also if you have 1,000 visitors at the same time. But that's showing the product, allowing them to add it to cart. But once you purchase, you also don't want to have people queuing up. So once you have, in our case, for example, here's a benchmark of the order intake service, which is a separate service from serving products and images and whatnot. This is a asynchronous service. So we capture the order and say thank you, and then we'll process it afterwards. And you can really easily scale this horizontally. So it's a modern way of basically doing asynchronous processing in a distributed service. So these kind of techniques you can roll out, and you can take it for part of your service. You don't have to reinvent the wheel for everything. You can take, okay, order intake, we need to be super scalable here. So we tackle that. So those are some of the reasons and benefits with a headless architecture. But what could it look like if we try to paint it up like this? Here we basically have, and this is one example with a stack where you would have in the headless services. This is typically you go to a vendor and you subscribe to, for example, authentication from Auth0 or payment with Stripe. They all use different protocols. At Crystallize, we use GraphQL as the API language. And there's kind of two different ways of approaching the services. Either you can serve the API directly to your frontends. So you could have some web frontends and maybe some app frontends. Could be React, Vue, Next, Gatsby. Or app frontend would be typically Flutter or React Native or any other of the frameworks out there. But what we find is that there's basically two ways of working with serving the information in the front end. And there's also one thing specifically if you're using React and Next.js, because Next.js you can easily add endpoints there. So you can have an API endpoint to catch a webhook, for example, which I know a lot of people are doing it that way, that you have the Lambda functions and the web services directly in the front end. What we find more and more is it's really more of a best practice to introduce a service layer, the service API, call it your business specific logic. And this would be an integration layer, ideally asynchronous as much as possible so that you can easily scale. And these are typically Lambda services, so web services that you deploy. And the benefit of this is, unless your service, like Crystallize, you can have a content hub for all your products. It could serve any number of frontends, and that's product information. But we also have functionality to capture an order. And to capture an order, there are a couple of things that need to happen, because you in the front end, you add it to your products to the basket, and then you submit it. And the way we do it is we submit it to our service API, where you have tokens and secure things, which are then passed to, for example, Stripe. That is either collecting a recurring payment or a first-time payment. And then this is also asynchronous, so we get the callback from Stripe. And all of this logic is typically in the service API, which means you can use the same code and same integration of services between your web frontend and your app. And that makes it really, really useful. And that comes into what we talked about with innovating, but when there's a new type of framework for the specific channel you want to add, you can just rely on the same services. And typically it's a combination of directly accessing, for example, as product information and images from Crystallize, and then to have the business logic and the special requests that are handled in your service API. So this is an example of a typical headless architecture with Crystallize for the e-commerce. I just want to show quickly GraphQL, because if you're hitting your services directly, like Crystallize as a PIM or backend for headless e-commerce, if we're going to serve multiple heads, it needs to be fast. And if I click here, I'm just opening up my playground. So this is the API in Crystallize. And this is just a query that I built to fetch some content from a long story e-commerce setup that we have. And here you see that it's a very semantic query. So you can read, this is the title, fetching the title. I want to fetch the content of the title. I want to have the text, I have the hero, it's an image, and so on. And what we see here is that I'm receiving first of all, the response is immediate. And I'm receiving structured information about my content. So there's two things that are important here. One is we need to be able to have a fast API if you're going to expose it directly to your app. And the other is with GraphQL, you're very easily able to remove things. Let's say I don't need the hero in this, which is, for example, a big image. You can just remove that, and then you transfer less data. So this is kind of the thing why we really like GraphQL. We can make it really fast and very easy for developers to learn the query language.
It frees up, but it frees you up a lot, but it's also really structured. So it's something between both worlds, which is really cool.
Indeed. Just on the service API, like and this is, you know, if you look at this part here, if you expand that, what do you typically put in the service API? And here it's, I would say in our case, we typically have a combination of GraphQL API endpoints, or one. Typically, you can make it a federated GraphQL so that you can plug in different microservices. And then it's also webhooks. And webhooks is typically you need somewhere to collect the callbacks from, if it's a Stripe or Klarna, or if it's collecting an event from Crystallize, for example, if a state changes in an order, for example. So we looked at GraphQL and how you can really tweak that to be very, very specific for the data you want to query. For webhooks, this is also a nice way of basically implementing a asynchronous way of dealing with processes. So I have here is a webhook catcher. Webhook.site is a debugger basically. And what I can do is, and this is just one example, I have an order here, it's packing, and when I'm done packing, I can set this to state ready. And what happens then is that we are firing off a webhook basically instantly when the event is triggered in Crystallize. The way this works, if you're connecting, you know, this is a standard event in Crystallize, so we're connecting this with an endpoint. So here you would be able to basically configure where should we send the information about the event that has changed. And you can also debug here where you see that this webhook here was now sent, and this is the data with the pipelines and the states that basically have changed here. And this is a good example of what you are adding to the service layer. It's the glue between maybe collecting a payment from Stripe that was reserved because the package is now shipped. So it's kind of making all of this business logic glue. And this is also typically where you add your, you know, tokens and API.
Yeah, all the secure stuff and syncing in between system stuff and yeah.
All the good stuff.
All the good stuff.
I think we have another interesting point, because now we talk about decoupling, separating responsibilities and concerns to get all these benefits that we talked about. And it's a creeping trend. I'm not sure if it's a good title, but this is I just saw on Twitter the other day, because in Next, which is, you know, it's a React framework for displaying, and well, it's a front-end framework. But what you can also do there is you can add webhooks or webhook catchers with Lambda, so API endpoints, and also you have the possibility to connect to databases. So you see that this example here is you have the layout definition, and you have the connection to the database. And this is actually, I would say, an example we've seen 20 years ago. It's the way the initial PHP things were written, where you have display logic, styling, and database code in the same file. So what we see is now some are actually building a monolith on the edge, where you have all the different concerns together. Sometimes it might be a good thing. You should just be really aware of what implication that has to your possibilities in
what you share also, yeah.
So that's what we wanted to talk about today. We will do a follow-up here with Håkon. where we will talk about our way of looking at the service API. We have built a
also a bit more technical stuff, right? So it's this is like a nice overview, high-end overview, but go a little bit more technical as well.
We will look at how the implementation for different services, both on the GraphQL side and on the webhook side, so sending and receiving for the service API. That will be the topic of next live stream with Håkon. Not sure if we do that one next week, but it will be the next one on this topic at least. Other than that, feel free to join. We have an open Slack community channel. Join there. You find it from our website, crystallize.com. That's it for us.
That's really nice. Better outro than mine. Thank you everyone for joining. It was really nice to have you with us today. And like Mr. Bort said, feel free to join the channel and ask any questions. And as soon as we have the newest concept out and ready to be presented, it will be a really interesting topic to see and actually see the implementation of how this can be managed and played around live, I guess. Right. So yeah, thank you for joining.